In this full video about addressing in IPv4, we are going to examine on one of the most common problems for students, which is basically evaluating whether a network address is valid or not. Considering a network address is consisting of an IP and a mask, not all the combinations are valid, and not necessarily all of them should end with a 0. Therefore, how do we know if a network address is valid? The rule in this case is pretty simple. If the network address has at least as many zeros at the end, that is, on the right side, as defined by the mask, then the address is valid. In the example from this figure, this address, which is 130, 206, and 34.64, we have 6 zeros, as you can see. Hence, if we have a mask /26, this network address is valid. We have as many zeros in the mask as in the network. But for example, if we have more zeros in the mask than in the address, in this case we have 24 as the mask, this wouldn't be valid, okay? Because this mask has 8 zeros on the right, more than the 6 from the address. Now a common tip. In general, valid network addresses will always be an even number, as they have to finish with some amount of zeros. So now let's take a look at some valid network addresses. In this example, all of these addresses are valid and all of them have the same size. Okay, we are starting at the bottom here with 34.0/26, and this would be the last one. This all set of addresses are consecutive. So many times we have to aggregate these network addresses. Usually we want to reduce and simplify routing tables. How do we do it? Thanks to the hierarchical structure of IP networks, two networks /26 with this kind of mask can be aggregated into one with /25, which will have as network address the lowest value of the two initial addresses. Okay, but we have to be careful. Let's see why do we have to be careful. So for example, in this example, in our case, network 1 and 2 can be aggregated into subnet A. Okay? In this case, the new mask is 25, and the network address would be the lowest of the two previous one, okay? Which is the one ending in 0. Okay? We can do the same with 3 and 4, 5 and 6, and 7 and 8, having B, C, and D, okay? With this resulting network address, okay? We can even aggregate it more, okay? For example, A and B could have another aggregation which would create subnet X. In this case, as we are coming with a mask with 25, we would have a new mask address 24, okay? AB would be X and C and D would be Y. Finally, we could take subnet X and Y and aggregate them both into a bigger subnet, which would have mask 23. Up to this point, everything looks pretty clear, isn't it? I guess so. So what should we be careful about, okay? The reason why we have to be careful is that up to this point, we have been applying a very simplified rule, okay? We have been following a very specific order. If, for example, we try to merge networks 2 and 3 instead of merging 1 and 2 and 3 and 4, we could have a problem, okay? For example, in this case, if we have 2 and 3 and we apply mask 25 and we get the lowest IP, we then would have this network address, okay? This network address, if you check, it's invalid. Why? Because we have a 1 in a place where we should have a 0, okay? You can check here the mask. We have all of these zeros, 7 zeros, and we have a 1 where we should have a 0. Okay, so this subnet is not valid. We cannot aggregate this kind of subnets, which are kind of unordered. Okay, the same would happen if we try to, for example, aggregate subnet B and C. We would then get this address, which is also invalid. It also has a 1 in a place where we should have a 0. Okay, so in this case, the number of zeros is not enough for the mask in order for the address to be valid. So how do we aggregate networks when they are not following a specific order? How do we do it? This is a good question. You should try to figure it out, but in any case, we will see it in class. And that's all so far. So thank you.